Hello again, everybody, and welcome to Algebra 2, Section 2 of our Logarithms unit. And in this unit, we're going to be talking about using the change of base formula and expanding logarithms. There's two parts to this because the change of base formula, extremely simple and quick. As you see in the middle of the page in orange here, the change of base formula is used to calculate logs that are not base 10. Because we said your calculator has a button on it, and it has a log button. And on these calculators, when you find a log button, the log button is always going to be log base 10. So it'd be nice if our calculator could help us with some of this. And so to do that, we're going to use what's called the change of base formula. And the change of base formula says what you see in the middle of your screen here, log base b of a. Understand, these are normally numbers. This might be log base 5 of 72. Well, all you have to do to calculate that is change them both to base 10. That's why we call it the change of base formula. It takes something that is of base b and allows us to use base 10 as our base. Now you can technically use any base you want in this formula, but base 10 is what the calculator uses, so we're going to change everything to base 10. So it says you can calculate a logarithm by taking the log of the a, the larger number in typing size, not the larger number, but just the one that's actually larger type, and divide it by the subscript, the base of our log. So you do log A divided by log B. This is going to be extremely simple and easy to do in your calculator. There's just one little thing you got to be careful of. So when we look at this example here in yellow, in order to calculate log base 3 of 56, now, we should be able to make some observations about this. First of all, we know 3 to the first power is 3, the second power is 9, the third power is 27, the fourth power is 81. So, it's between 27 and 81, 56 is. So we know it's got to be 3 point something, because 3 to the third power is 27, 3 to the fourth power is 81, so we know it's 3 point something. That's using common log sense. But in order to get that actual decimal as accurately as we can, we're going to use the change of base formula. We're going to rewrite the problem as log 56 divided by log 3. We've changed the base from base 3 to 2 logs of base 10. That's the change of base formula. So then you can just type this right into your calculator. The place we have to be careful when using a calculator, when I type in log, it's going to make a parenthesis. So when I type in 56, I need to make sure I close the parenthesis before I divide by log 3. So you type in log 56, close the parenthesis, divided by log 3, and I'll close that parenthesis as well, and we get 3.664. Now, it is important that we use 3 to 4 decimal places when doing this. And that's because we're talking about exponents. We're talking about powers. If you round to the nearest tenth for a power, you can be off by a lot in your answer because an exponent changes a number quickly. So you want to make sure you have 3 to 4 decimal places when you state your answer, or else that's not going to be very helpful in actual calculation. So remember what this means from our definition of logs. I should be able to take my calculator and do 3 to the power of 3.664, and I should get 56 or something close. I got 55.99, so that's obviously very close. But if I would round that to 3.7, 3 to the 3.7 power is actually 58.3. So I'm not even within a whole number of correct when I go to check my answer. That's why it's so important that we round to 3 or 4 decimal places. All right, so that's the change of base formula. Pretty straightforward and simple. Now we're going to talk about expanding logarithms, and this is going to be properties that come in really handy when we get to solving and applying all of this in higher level courses. All right, so the other thing we're going to get into today is going to be the properties of logarithms, and we're going to use those to what's called expand logarithms. All right, the 3 properties that we're going to work with today are very simple ideas. They get a little bit ugly sometimes when you try to apply them, but we just have three properties. And remember, properties are things that are just simply true. And so the product property says the log of x times y. You can split that up into two separate logs. When you have a multiplication inside of a log, you can split that into two separate logs and it will become an addition. So the log of x times y is equal to the log of x plus the log of y. It's just a property. It's something that's true. And like I said, it has a lot of applications when we get to higher level solving stuff, especially with some money math that we're going to get into next year. All right, the quotient property, it should kind of follow common sense. The multiplication property split into two logs with addition. The quotient property simply says the log of x divided by y then can be split into two separate logs by using subtraction. So if you have a division inside of a log, you can split it into two separate logs utilizing subtraction. The final property is the power property. And the power property says if you have an exponent on something you're taking a log of, log to the xy power, that can be rewritten as a multiplication where the y comes out and multiplies by the log of x. So you have y times the log of x. These are just properties, just statements that are true, and we're going to use these to apply them into some expanding and condensing over the next couple of days. But then we're going to get into solving during our last section. All right, so let's practice a couple of these. They'll get gradually more difficult as we go, and then you'll be able to get on with your homework. All right, so now our step is going to be to apply these properties that we just learned. And so we're going to start with a couple simple examples and go on to slightly more difficult as we go. You're going to be asked to expand this where you have the log base 4 of a times b times c. We can then look at that and go, well, those are all multiplied together. There's three parts multiplied together. So I can split that into three separate logs. Log base 4 of a plus log base 4 of b plus log base 4 of c. That's it. That's the rule. That's our product rule in action, where I'm saying I have log base 4 of all three of those multiplied together. Because they're multiplied, the product rule says I can split them up into three separate logs using addition. You notice I kept them all log base 4 because when you separate them, the log doesn't change. It just is now we have three different logs to work with. All right, let's move on to number 2. In number 2, we're going to have two different properties working in the same problem. I have a multiplication and a division. Log base 2 of a times b divided by c. Well, again, that's going to split into three logs. Log base 2 of a plus log base 2 of b, because I have a times b. The product rule says if you have the multiplication inside of a log, you can split it into two separate logs. Then I have divided by c. Well, the quotient rule says if you have a log division inside of the log, you can change that into a subtraction. So that's simply log base 2 of a plus log base 2 of b minus log base 2 of c. Again, it's just simple application of properties. All right, 3 and 4 are going to be slightly more difficult. Number 3 is only more difficult because it's a two-step problem. I recognize I have a multiplication in there. So it's log base 5, x to the third, plus log base 5, y to the fifth. Okay? I've gone ahead and split it into two logs. However, there's another property that comes into play here. I have exponents inside of my logs. The power property says you can move that exponent out front as a multiplier. So our completely expanded logarithm is 3 log x, log base 5, x, plus 5 log base 5y. We'll see if I can squeeze that in there. All right, sorry, we ran out of space a little bit there. But 3 log base 5 of x plus 5 log base 5 of y. This is application of properties. And again, right now it looks like we're just doing random stuff. But this all has application later on. Right now, we're just directly applying the property. If you have a multiplication, you can split it into 2 logs with an addition in between. If you have a division, you can split it into 2 logs with a subtraction in between. If you have exponents, those exponents move to the front as a multiplier. Those are the 3 properties of logarithms. All right, our last one today is going to be a little bit trickier. You see this square root of x in here. Well, something we haven't talked about yet in here, but we should hopefully have heard at some point, is that a square root is really an exponent. A square root is the same thing as the 1/2 power. So this problem is really x to the 1/2 power divided by y to the 3rd. All right, that's important because now the square root falls under the power property. So anytime you see a radical, you're going to make it into an exponent that is a fraction. A cube root is going to be the 1/3 power. A 4th root is the 1/4 power. Roots are simply fractional exponents. All right, so our expanded form. We're going to go ahead and split this into a subtraction. Because it's a division problem can be split into 2 separate logs by using subtraction. Then we have exponents in here. Those exponents move to the front. 1/2 log x minus 3 log y. The properties of logarithms. There's not much to the calculation, it's just keeping them all straight. All right, hopefully this one is not too challenging for you. It's a little bit difficult and definitely one that's easier to do in person. But we're getting down there, just a week and a half to go. All right, good luck.